Hi friends, how are you? I hope everyone's doing well. Today we're just going to have a quick video introducing the cosine function. So before we left and we last saw each other in person, we spent a lot of time talking about sine, and hopefully you've completed the first two online assignments refreshing your memory on sine, but we're just going to do a quick recap and then talk about the cosine function. So let's remember that when we were using the sine function, we talked about how sine of some angle theta was equal to opposite over the hypotenuse, or in terms of circular motion, like we were doing in a Ferris wheel, if we drew a triangle inside this circle and we had this angle theta, well, the opposite I'm going to call y, because we measured the height, which would be the y coordinate. And in this case, the hypotenuse would be r, or the radius of the circle. So we could also think of sine theta as y over r. So when we were interested in finding the y coordinate, we used the sine theta function. And that y coordinate helped us find the height of the Ferris wheel. We're now going to transition to cosine. So for cosine, rather than finding the height at different positions around this circle, it's going to measure the horizontal distance, meaning how far away to the right or the left are you from the y-axis. So before we were referring to the height, how high are you? And we talked about how if you were above the x-axis or you were between 0 and 180 degrees, you would end up having a positive sine value because your height was positive. But now we're going to be looking at not in terms of how high you are around the circle, but rather how far to the right and left you are from the y-axis. Okay, so I'm going to erase some of the stuff I have here in the circle, and we're just going to label it with some of our important things. So remember our four kind of critical angles that we should all know is we know 0 degrees is here, 90 degrees is here, 180 degrees, 270 degrees, 360 degrees, and we could keep going around the circle a bunch of times. Also, just a reminder that in terms of the quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4, as you go around the circle. So just to kind of recap, we had talked about how sine would be positive if we were in quadrant 1 and quadrant 2, because you were above the x-axis, or you made an angle of rotation that was less than 180 degrees. And then we also talked about how sine would be negative when we were below the x-axis, or between 180 and 360 degrees. And then we had two special spots where sine was equal to 0, where you hadn't moved up or down, and that happened at 0 degrees, 180 degrees, and 360 degrees. Our other special points were at 90 degrees, because that was the highest that sine could be, and at 270 degrees was the lowest that sine could be. So I'm just going to write that here to help us remember, right? So we know that sine of 0 is 0, because we haven't moved up or down. Sine of 90 is positive 1, because that's when we're at the highest point. Sine of 180 was 0, because we haven't moved up or down. Sine of 270 was negative 1, because we're at the lowest point in the circle. And sine of 360 would be back to 0, because we had called it the midline, right? I haven't moved up or down yet. So those were our three critical values for sine. For cosine, we are now measuring right and left. So we're not talking about height, but rather are we to the right or left of the y-axis. So in this case, if we end up in this first quadrant, say my point's over here, right, our cosine value is going to be positive because I am to the right of the y-axis. Right? I want you to think again about what other quadrant quadrant 1, 2, 3, or 4, where else would you be to the right of the y-axis? Well, that would happen in quadrant 4, so any angle of rotation that lets you in quadrant 4 would be positive for cosine. Then, in terms of now going to the left, the two quadrants where we would be to the left of the y-axis will be in quadrant 2 and quadrant 3. So we can say that cosine is negative in quadrant 2 and quadrant 3. So sine, again to recap, measures up and down. So we have these quadrant 1 and quadrant 2 where we're above the x-axis are positive for sine. And quadrant 3 and quadrant 4 are negative for sine. Cosine, which measures right and left. When we are in quadrant 1 and 4, we're on the right side of the y-axis, so we're positive. When we're in quadrant 2 and 3, we're on the left side, so cosine's negative. So in terms of our exact values, here we were able to figure out when sine was 0, sine was 1, and sine was -1. We're going to do the same thing for cosine. So cosine of theta, that works actually. So I'm going to write this up here how I had it before. So when we are trying to measure horizontal distance in terms of right and left, we're going to use the cosine function. And we can say that cosine of 0, and we're going to find the important, or quadrantals is actually what these four angles are called. Cosine of 0, cosine of 90, cosine of 180, cosine of 270, cosine of 360. So in terms of right and left, I want you to think what angle of rotation would you be farthest to the right? Right? And we would be farthest to the right here at 0 and 360 degrees. So 0 and 360 degrees are going to be our maximum, the farthest to the right. So that means cosine of 0 and 360 are 1. Where are we farthest to the left? Well, we're farthest to the left right here, which would be after I made a 180 degree rotation. So cosine of 180 is going to be -1. Now, where am I in the middle? Where have I not moved to the right or the left? Well, if I make a 90 degree rotation, I'm on the y-axis, so I'm not to the right side or to the left side. So that would give me a cosine of 90 would be 0. And if I go all the way around to 270 degrees, same thing, I'm not to the right or to the left, I'm on the y-axis. So cosine of 270 would be 0. So I want you to take a quick second, one, to copy these 6 problems down. Sorry, 3 of them ended up on the bottom of the page. And there's 6 different cosine problems with different angles. And I just want you to decide, are those cosine values positive, negative, or 0? So take a second, pause the video, copy down the 6 problems, and based on what we've talked about, I want you to think if cosine is positive, that means that once you've done the degree rotation, are you on the right side? Cosine would be negative if after you did your degree rotation, you're on the left side. Cosine would be 0 if after you did your rotation, you're on the y-axis, you're in the middle. So pause it, copy down the 6 problems, and give it a shot, and then I'll share the answers. Remember, it helps to draw. So I'll model one for you in case you need. So 43 degrees would be somewhere around here, right? And if I plotted a point right here, would that point be on the right side or on the left side? Well, it would be on the right side, so that means we're going to have a positive cosine value. Okay, so I want you to repeat for the 9 other ones. Okay, so for cosine of 90 degrees, I'm going to label these with a black dot. So here's my 43 degrees, here's 90 degrees. Am I to the right, to the left, or am I in the middle? Well, I'm in the middle, so that would mean my cosine is 0 because I'm not on the right or on the left. Okay. Cosine of 170, well, a 170 degree angle would take me a little bit before 180. And that point is now on the left side of the y-axis. It's actually pretty far to the left. Remember, the farthest to the left I could be is at 180, so I'm getting close to the farthest left, so that would be negative. 350 degrees would mean I go almost all the way around, right? I stop about here. And now I am on the right side. Again, I'm almost as far to the right as I could be, right? I'll be as far to the right as I could be at 360, but at 350 degrees, I'm at the right side, so cosine of 350 degrees is positive. 220, so I have to go 180 degrees and some past it, right? But not quite to 270. And again, this dot is now on the left side. So that means after I did a 220 degree rotation, cosine of 220 would be negative. And then 270. So if I made a 270 degree rotation, I would be right here. And I'm not on the right side or the left side. I'm right in the middle. So that means cosine of 270 would be 0. Okay. We have 3 more. Sorry, these should have been bumped up. It must have cut off weird. 10 degrees would just mean I made a little angle of rotation, a little tiny 10 degree rotation. And that 10 degrees would put me on the right side, so I'm positive. 92 degrees would mean I went past 90. I'm up here. And now I'm on the left side, so cosine of 92 is negative. And then 375, remember we can go past 360, so I would do a 360 degree angle and then go a little bit past it to be at 375, which would put me on the right side. Okay, so remember, sine, you're looking at height, up or down. If you're above the x-axis, sine is positive. If you're below the x-axis, sine is negative. And for cosine, we're looking at right or left. So if you're on the right side, it's positive. If you're on the left side, it's negative. Okay. So let's also just recap, even though we already did this, the quadrantals. So 0 degrees, 90 degrees, 180, 270, 360. The answer doesn't need to be positive, negative, or 0. You can actually figure it out. So it helps, I think, to draw our circle. Remind ourselves, here's a 0 degree rotation, 90 degrees. We always go counterclockwise unless we're doing negative angles of rotation. 180, 270, and 360 would get me back at 0. So cosine of 0 means I'm farthest to the right, right? There's nowhere more right on this circle. So that would be the biggest I can be. So that's going to be positive 1. 90 degrees, I'm not on the right or the left of the y-axis. I'm on the y-axis, so that means it would be 0. 180 means I'm as far to the left as I could possibly be. If I was riding this Ferris wheel, there'd be no one to the left of me. So that puts me at -1. It's the lowest cosine value. Cosine of 270, I'm at the bottom, so I'm not on the right or the left. I'm right in the middle again on the y-axis, so that would be 0. And then 360 degrees would be I rode this Ferris wheel all the way around, and now I'm as far to the right as I can possibly be. So I'm back to being +1, the maximum. So cosine of 0 and 360 are going to help us when we go to graph, find our maxes. And then 180, right, will help us find our min. And at 90 and 270, we would be at a height of 0. Or sorry, to the right, or we wouldn't be to the right or to the left. We would have a value of 0. Okay, last but not least, we're going to practice like we did before, ordering values from least to greatest. So when we did this for sine, least to greatest meant lowest to highest. Right? For sine, we did what was the lowest to what was the highest. Oh, geez, I can't spell. Whoop. Highest. There we go. Been out of school too long. And for cosine theta, when we go to put it in order from least to greatest, we want what is the leftmost point to what is the rightmost point. So again, it might help to draw a circle. Here's 0, 90, 180, 270, 360. And let's plot these and label them. So 45 degrees would be about here, right? Halfway to 90. So this is my point A. Okay. 181 degrees, right? That would be a little bit past 180. So here's 180 to 1 degrees. So that's my point B. 93 degrees would be a little bit past 90. So that's my point C. 271 would be a little past 270. Oh, that's my point E. Sorry, I skipped one. And D, 350 would be, I haven't yet hit 360. So here would be my point D. Okay, so now rather than going lowest to highest, which would be what we would do if these were all sine values, but we're trying to order our cosine values. So we're going from left to right, not low to high. So what point is the farthest to the left? Well, that would be my point B. And we could either just put a B on the line here, or you could write cosine of 181. I don't have a ton of space, so I'm just going to use B. So we've done that one. And then keep going, moving to the right. What would be the next point you would hit? Well, point C would be right here. That would be the next farthest to the left, right? Both B and C, cosine of 181 and cosine of 93, are negative because they're on the left side. So C would be next. So I've done B and I've done C. So now all three of my remaining points are positive because they're all on the right side. But if I keep moving, right, B was my farthest to the left, then C, and now I have E. E is just barely to the right. It's just a little bit past 270, which wouldn't be to the right or to the left. It would be at 0. So my next point is E. And then now I'm left with two more, A and D. Based on my drawing, you can see that A isn't quite as far to the right as D, but it doesn't look like a huge difference. But just remember, 360 is the farthest to the right you can be. So something closest to 360 is going to be the highest because it'll be the closest to 1. So going from left to right, I had B, then C, then E, then A, and then my greatest value would be D at cosine of 350. So A, D. Okay, so I hope this video was helpful. Please now complete the worksheet that goes along with this just to see if you got it. Remember, draw a picture, it helps. It's really hard to do this without drawing. So let us know if you need anything and send some questions our way. If not, I hope you are successful in completing the worksheet. Remember, this assignment was optional. So do the best you can, and you will learn more about this cosine function in your next math class, but we just wanted to give you a little bit of a preview. Hope you are all doing well. Bye.